Okay, so this one probably looks like a doozy. If you're asked to subtract, yeah, it's ugly. Keep in mind the bottom line, that we need common denominators when we're adding or subtracting fractions, so we certainly don't have them yet. Let's do a little manipulation. So look carefully at what I just drew. I might have to stare at it for a second, but I multiplied the green and what is this, tan? The green and the tan stuff is 1. If you were to divide this by this, it'd be 1. So I'm multiplying this whole fraction by 1. And I'm multiplying this whole fraction by 1. So I'm not fundamentally changing it, I'm just changing its appearance. We multiply these guys out, we get a to the second, b to the fifth. Oh, and the reason why I did it, once you look closely, I hope you would see a to the third times a to the second gives me a to the fifth. B to the second times b to the fifth gives me b to the seventh. A to the fourth times a to the first gives me a to the fifth. B to the first times b to the sixth gives me b to the seventh. Common denominators right across the board. So let's go ahead and do that. A to the fifth, b to the seventh, and we're subtracting that blue fraction is now 2ab to the sixth over a to the fifth, b to the seventh. We're adding 3 over a to the fifth, b to the seventh. Okay. Now we have common denominators. We can write the top. A to the second, b to the fifth, subtract by 2a, b to the sixth, plus 3, and it's all over now the common denominator, a to the fifth, b to the seventh. So, what I'm thinking about is factoring, because I have a squared, a, now a. Looks like it's almost a quadratic in terms of a, but that's not going to be factorable. I think this might be where you have to stop. Yeah, this is it. This is a weird one, but when you subtract, it doesn't do you much good. Just gives you one big jumbled mess.